necessarily means it's available to plant unless you have zinc to help the plant assimilate, to pull in that phosphorus. So that's why we add zinc. The other thing that zinc does for in furrow is it's a precursor to what a PGR, have you ever heard of auxin? All plants, all these leaves here have auxin in them. And if this plant, just say it goes under stress, and then if I synthetically can spray auxin, I can help that plant recover from whether it's a hail event, which it went through. I think Radiate was sprayed on that, which is an auxin. So zinc is a precursor to auxin. So if you put it in furrow, what you'll do is you'll trick the plant into being photosynthetically active by helping phosphorus and zinc. The phosphorus gets assimilated by the zinc turns on the auxin. The plant says, I'm photosynthetically active. It starts secreting sugars and pulling more nutrients. And that's where you can take a treated plant and an untreated plant and you'll see a root difference. And you're thinking, what's going on? That's what I call plant stimulation. The other thing, the carbohydrates, is a sugar package that helps. It's almost like putting a pint of STP in a fire or in your gas tank just to help your engine run. Same thing you're doing for the plant. The carbohydrates, your STP package. Yeah, remember I said 6 bonds chelates the zinc and makes it available? And we put this in to chelate our phosphorus and the zinc in the Black Label zinc product. We know what at least the amount of bonds are in this. We don't know how many for sure. We're still trying to figure that one out. But we know it's well over 200 bonds. So for all the things that are trying to get access to those nutrients that you reacted with, you got 200 bonds protecting that metal or the phosphorus in Black Label zinc. And our Blackjack manganese and zinc, the same thing's going on. So some people question, well, if this 6 bonds allows me to handle it, but yet it's challenging to get into the roots or the leaf, this has 200 bonds. Why the heck would I want to use that? That's going to be a real challenge to break down. Because this is a plant-based material, when you spray it foliar or in the soil, it actually, plant sucks up the organic acid and brings the nutrient with it. So it acts as a good adjuvant for assimilating nutrients. And that's why we get a response. Now, you can take Black Label zinc and broadcast a gallon right over the soil, and that would be equivalent to you putting out 22 pounds of phosphorus. Is it pound for pound? No. You got 2.6 pounds is equal to 22. Well, how the heck is that the equivalent? It's all based on this organic acid making it available, not tying up into the soil. You take 100 pounds of potash material, it gives you 60 pounds, correct? Now, how many of that 60 you put out this spring is available for the crop that year? Most universities will tell you 17 to 20% at best. You have a good heat, moisture, good microbial activity. The rest of that, you can build a soil test, which is a good thing if we have low K soils. But if you can put out a material that's 100% available, you don't have to put out 100 pounds. And that's the same thing we're doing from a phosphorus standpoint. The other thing is this organic acid has a lot of carbon. There's 4 carbon sources. So if you mix this with top dress and wheat, for example, I'm going to go out with 50 pounds of nitrogen. I want to put some phosphorus and zinc, kind of help the biomass with phosphorus. If you're growing alfalfa, you need a lot of phosphorus to get biomass, tonnage. I'm going to put a little bit of this out, 2 gallons. Well, not only will you add the zinc and the phosphorus, you'll also stabilize the nitrogen and do all the other things. Not only stabilize the nitrogen, make the nitrogen safer. So what do? We burn the wheat when we put on a load of nitrogen, right? Then 3, 4 days, 5 days later, we go check and see if it's come out of it and it's worse. Why is it worse? Anybody can tell me? What's UAN? 50% urea, 25% ammonium, and 25% nitrate. That day you burn it, that ammonia burns the day you put it on. So you put it in the morning, go back in the afternoon or the next day, and you got some leaf burn. So 4 days later, you go back and it's worse. Well, that urea component converts to ammonia. You get some volatility. Then it goes to ammonium, which then it's stable. Won't burn as ammonium. The microbes have to take that ammonium, convert to nitrate. Then the nitrate, you got a corn plant here with roots, soybean plant, whatever plant you're growing, it wants to pull up nitrate nitrogen. And it has to detoxify that nitrate nitrogen back into ammonium. And then it puts it into a polyamine ring and uses it. It's a funny thing. You start over here, ammonium goes to nitrate, goes back to ammonium, and then it goes to polyamine ring. But a bunch of chemistry. Anyway, the point is, you add this carbon, you'll stabilize the nitrogen volatility. You convert it into organic nitrogen from inorganic nitrogen, so then it's stable, won't leach. It's still plant available. You added 4 carbon sources, so when you foliar apply, you don't get the burn, because the carbon helps detoxify the nitrogen to the plant. So, first thing when people use Black Label the first time, they say, well, gotta watch my language, the stuff's black. The second thing they say, well, I got a yield bump, but maybe didn't cut any of my phosphorus back. Still use the same amount of phosphorus. I believe a lot of it's coming from this detoxifying the nitrogen, stabilizing the nitrogen, getting better efficiency of your nitrogen. The last group just came through here said, I use 3 gallons of Black Label zinc on my corn, and I watch all my neighbors, and we got dry in my area. My corn didn't fire up as fast as everybody else's corn. What's going on there? I said, well, you know, it's always good to have balanced nutrition, but this organic acid will help liberate the chemical. You got a corn plant here. It's no different than your truck you drove here to get here today. Your truck has antifreeze or radiator, right? It's got 50% antifreeze and 50% water. If you were 100% of either, it would overheat real quick and would freeze and you won't be going anywhere. So it's 50-50. The corn plant's no different. It's got to have 50% water and it's got to have 50% potash. So if you can make potash more available, the plant's able to fight cold stress, drought stress. That's the antifreeze of the plant. The other thing potash does is it hooks the sugars together to form glucose. So if you're looking at tip fill, I don't know what this ear looks like. You know, some people say, and this got good tip fill. Some people say, you got poor tip fill. What do they say? Not enough boron. Add some boron. And boron is a trap cop, helps nutrients move, but the other thing is potash deficiency. Potash hooks those sugars to form glucose, which this is the energy. So you can run out of potash. So with that, guys, any questions for me? I hope it'd be, if anything, go home, pull a soil test out, and look at that soil tilth ratio. And see if you can say, well, I know that field over there is kind of mallow, it's easy to work. And see what I told you works. If anything you can remember today, remember that. You're welcome to walk through and look at the different treatments. I don't know which station you're going to. Where'd you come from? The soybean? So then you'd be going to the corn. So. But there's a lot of technology with this fertilizer that's, you can see I'm trying to explain some of it. It makes your job tougher now. Basically. So you got to sort through all the BS, make sure you're spending the right amount of money. So, all right. Shelby, can I turn this off?